So the next speaker, the last speaker for this lightning session is Yichi Zhang, and he'll be telling us about high-effort crowds, limited liability via tournaments.
Right. Hi, everyone. I'm Yichi Zhang from University of Michigan. I'm very excited to share this work. It's a joint work with my advisor, Schoenebeck. So let's consider the setting where there's a crowdsourcing setting. A principal wants to collect some labels from a set of tasks from a group of agents. Then the question is, how to reward these agents for their effort, just given their reports. Additionally, we want the payment to satisfy limited liability, which means in any cases, you can never charge agents for money. The payment has to satisfy ex post non-activity. So previous literature provides some good insights on this. So like we can use spot checking mechanism or peer prediction mechanism. So what the amazing thing about this mechanism is that if we put reports into the mechanisms, it will output some scores. And a good part of it is that when agents exert high effort or they report truthfully, the scores are in expectation maximized. So what's the problem here is that because we are reasoning about the expectation of the scores, we have to do linear transportation of payments so that the payments have to be linear transportations of the scores so that we can guarantee this truthfulness and other properties. So the diagram looks like this. We collect reports from agents and put them into this performance measurement. You can consider that as a peer prediction mechanism, and we will output some performance scores. These scores can be negative, can be anything. So we need a payment function, which is a linear one, to scale it. Basically, we mean adding a constant and scale it by a constant so that we have final payments to incentivize agents. Our setting is that we want to solicit a goal effort, not just like truthful report. So the effort agents are strategic in that, which is a real value between 0 and 1. And the agents are homogeneous with identical cost function. We assume higher effort basically means there are lower noise in the reports. And here, let's just assume agents are truthful for a moment. And what we want is that we want to guarantee a desired equilibrium. The desired effort C is a symmetric equilibrium, so that everyone exert this C effort is an equilibrium, and no one wants to deviate. So let's see what's the problem with this linear payment. The issue is that linear payment functions plus limited liability will lead to ridiculous payment. Let's consider the first case where the performance scores can be negative infinity. And in this case, there's no constant that you can find to guarantee limited liability. Right? You want to guarantee everyone is non-negative in ex post sense. That's impossible. But even though the performance scores are bounded below, there are still issues. And I can provide you with an example. For time limitation, I cannot cover this, but the main idea is that there's a desired equilibrium. For example, everyone is exerting full effort. And you want to guarantee this equilibrium where everyone just, the cost of effort is $10. However, if you apply a linear payment function, it ends up that you have to pay everyone $100, which is like 10 times their cost. It's a waste of money. So linear payment function experience some problem, and our solution is that let's forget about this truth-telling equilibrium. We replace the linear payment with a rank order payment. And maybe we can do something better than that. So rank order payment, basically, you can consider we are ranking agent scores and design a payment function on the ranking of the scores. For example, the winner take-all is a very well-known rank order payment function. So our first result is that we kind of optimize the rank order payment function. For example, when agents are risk neutral, we figure out that winner take all is actually optimal. The main takeaway from this slide is that we ran some agent-based modeling, and this is the comparison between the linear payment function and the rank order payment function. You can say that in other cases, whether the scores are unbounded below or bounded below, the gap between the linear payment function and the rank order payment function is very, very large. And furthermore, rank order payment function, it seems like is almost identical to the minimum payment you can achieve. So in this setting, basically we are suggesting the linear payment function is such a bad idea, and perhaps rank order is a better choice. So we have more results on this. For example, we empirically evaluate the state-of-art peer prediction mechanism and scoring spot checking mechanism, and kind of provide some suggestions on which ones to use in reality. But I will use one more slide to summarize something different. So this is a discussion on the robustness of truth-telling equilibrium. Recall that we ran this rank order payment function that are not linear, right? So how robust is the truth-telling equilibrium under this rank order thing? It turns out that for some of the performance measurement, that is indeed the issue. And the intuition is that lying, by theory, will decrease the expected score. However, it will increase the variance of the score. And if we are rewarding agents based on ranking, for example, in this yellow area, that's winner take all, lying can be beneficial in this case because the variance is larger. I have a higher chance to gain the first prize. So we have some intuition in fixing this. I think that's an interesting next step. So I will end my talk here. Thanks.